Now let us move on to internetworking. As far as the network software part is concerned, we were discussing about different functions of network layer, right? And we have already covered two different functions. Those were routing and congestion control. And until now, we have implicitly assumed that there is a single homogeneous network, right? Both of our center machine and destination machine belongs to homogeneous network system, and each system runs the same protocols in each layer. That was our assumption, right? Unfortunately, that is not the reality. In real network, a lot of networks may be there, like completely different heterogeneous networks are there, like LANs, MANs, WANs, and each network may have its own protocols and algorithms for their working. And our source machine and destination machine may be in a completely different environment. So it's not an easy job to communicate between these two systems through these heterogeneous networks. How to interconnect these heterogeneous networks, that is a challenging task for this network layer. So we will discuss those things in this session. So our major concern is about the issues that arise when two or more networks are connected to form a internet. Internet is actually interconnection of different networks. Heterogeneous, maybe heterogeneous networks. Okay. And if you think about the diversity of networks, why such a diversity in networks and network protocols? Yeah, there are definitely reasons behind that. First of all, just for example, TCP/IP. Most of the personal computers run TCP/IP as a network base, right? But many large businesses have mainframes running IBM's SNAs. SNA is the systems network architecture developed by this IBM for business purpose networking. And then we have the ATM networks. We have already seen what is the ATM network, right? A substantial number of telephone companies operate on this ATM network, and some personal computer LANs still use this novel NCP bar IPX or Apple Talks. Finally, this wireless networking is an up and coming area with a variety of protocols, right? So of course this heterogeneity is inevitable, and the only thing we can do is to find some solution to the issues or challenges raised by this heterogeneity. Now let us see an example for different networks interconnected together. So this is an example for a corporate network with multiple locations tied together with a wide area ATM network. So at one location, the FTDI optical backbone is used to connect this Ethernet, this wireless LAN, and the corporate data center's mainframe network. So why these networks are actually interconnected? Yeah, definitely any user in any of this network need to connect or communicate with some other user in some other network. So there should be a path, right? So this should be possible for any of the user, and he should be able to access the data in any of the system. That's why these heterogeneous networks are actually interconnected. We are always saying that networks are different, heterogeneous networks are there. So how they differ actually? What are the different parameters in which different networks differ? So let us see those things. So these are the different topics we have to cover. So how different networks differ, and how different networks can be connected together, and how paths can be established in concatenated virtual circuit, that is connection oriented manner, and then connectionless manner. Then a new technique for communication, that is tunneling, then routing through this internetwork, and finally fragmentation of different packets. Now coming to the first point, how these different networks actually differ. What are the different parameters upon which these different networks are different? Obviously there can be differences, like different networks may use different encoding schemes. Say one is using some binary encoding, some other using Manchester encoding, like that. And also they may have different frame formats, like some may use the Ethernet frame format, some other may be token ring, like that. But these are not concerned of a network layer, right? The network layer is actually concerned about the network layer of different networks, right? So frame formats and all is not at all affected by this network layer. So what are the differences in the network layer and depot? That is a concern here. Okay, so first one is the service offered by different networks. Some network may offer connection oriented service, some other may offer connectionless service. So when packets from a connection oriented network must transit a connectionless one, the packets may be reordered, right? Because in case of connectionless service, there is no guarantee that packets are delivered in order. So in this case, something is happening the sender does not expect and the receiver is not prepared to deal with. Next, different network may use different protocols in the network layer. Some may use IP, some may use IPX, SNA, ATM, etc. So that is another issue. So in that case, protocol conversion will be required for communication between two different networks, and that is very difficult. Addressing is also another issue. Some network may use some flat addressing scheme, whereas some other use some hierarchical addressing scheme like IP, that's also a problem. So some address conversions would be required, which requires some directory system and all. Another issue in case of multicasting, because some system may not support this multicasting. So if a particular multicast packet how to travel along some network which doesn't support this multicast, then we have to generate separate packets for each destination in that case. Another issue is packet size. Every network will have its own maximum packet size. Just for example, suppose a packet from a network whose packet size is 8000 bytes, how to travel through another network in which the packet size is 1500 bytes. And differing quality of service is another issue. Just for example, suppose a packet which has a real-time delivery constraint, how to passes through a network that does not offer any real-time guarantees. In that case also it's an issue for communication. Now this error, flow and congestion control also differ among different networks. Just for example, if the source and destination networks both expect all packets to be delivered in sequence without error, but to think about situation that an intermediate network that discards packets whenever it feels some congestion, the application will fail, right? Yeah, that's an issue here. And also the security mechanism, parameter settings and accounting rules and even national privacy laws can also cause different problems. Now, how these different networks can be interconnected? Yeah, we have a set of devices we already seen, right? So in the physical layer, networks can be connected by repeaters or hub. So which just move bits from one network to an identical network. One layer up, we have the bridges and switches which operate at the data link layer. So they can accept frames, examine the MAC address and forward the frames to a different network. So we can do some minor protocol translation. Just for example, you can forward the frames from Ethernet to FTDI or Ethernet to wireless network, right? And in the network layer, we have this routers that can connect two different networks. If two networks have dissimilar network layers, the router may be able to translate between these packet formats, and such a router that can handle multiple protocols is called multi-protocol router. And in the transport layer, we have the transport gateways which can interface between two different transport connections. So just for example, a transport gateway could allow packets to flow between a TCP network and an SNA network. And finally, in the application layer, application gateways are there which can translate message semantics. Just for example, a gateway between internet email and an X.40 email must pass the email messages and change different fields of this header part in this message. Now, our focus is on the internetworking in the network layer, right? So just to see how that differ from switching in the data link layer, let us see these two examples. In the first figure, that figure A, these two different LANs are connected using a switch. Suppose the source machine S wants to send some data to destination machine D, and these two machines are on different LANs or Ethernet and they are connected using a switch. So this frame reaches switch analyzes its MAC address and find that the destination belongs to LAN 2, so it will just forward that frame to this LAN. Now let us see the same situation, but these two LANs are connected using a pair of routers instead of a switch here. And these two routers are actually connected using a point-to-point line, maybe at least telephone line, and these two routers may be far apart, maybe thousands of kilometers apart. So there can be a subnet in between. We are not bothered about that for the time being. Now upon receiving this Ethernet frame from this LAN 1, this router will extract the corresponding packet part, and it will examine the corresponding destination IP address or destination network address, and it will consult the routing table to find out the outgoing link and find that this should be forwarded to this remote router. Okay, so it will form a new frame based on the protocol used in this point-to-point link. Maybe a different frame format may be used by this point-to-point link. So such a frame will be constructed and that will be put along this link. Now when this router receives the corresponding frame, the same thing happens. The corresponding packet part will be extracted by this router and it will consult the routing table and finds that this should be forwarded to this LAN. So it will construct another Ethernet frame. Okay, and that will be forwarded to this LAN. So the main difference in the case of switch and router is that with a switch, the entire frame is transported on the basis of its MAC address. Whereas in the router, the packet is extracted from the frame and the address in the packet, that is the network address, is used for deciding where to send. Switches do not have to understand the network layer protocol being used to switch packets, whereas routers need to.